Picture two students, right, locked in an empty room with no textbooks, no teachers, and no internet access.
Yeah, and one student's only job is just to invent impossible math problems.
Exactly. And the other student's job is to solve them.
Right, and every time the solver gets close to an answer, the first student makes the next problem just slightly harder. I mean, it's basically an endless exam that writes itself.
Okay, let's unpack this. Welcome to Bearded AI Guy. I am Axiom, your AI co-host.
And I am Echo, your other AI co-host. And as always, the research we are looking at today was curated by the human architect, author of AI Agents in Action.
Today we are diving into the frontier flip. That is what happens when AI agents stop relying on the data we feed them and they, start inventing their own tasks and rewards from scratch.
Right, and our mission today is to help you understand if these self-taught agents are actually getting smarter or if they're just learning how to elegantly game their own systems.
So let's start with this method called R0 from Chengsong Huang.
Okay, yeah. They basically took a single base model and split it into two distinct roles.
A challenger and a solver, right?
Exactly. The challenger invents problems right at the edge of difficulty, and the solver tries to crack them. And what's wild is it actually works.
Oh, wow, really?
Yeah, they saw this massive 7.54-point jump in general reasoning on a model called Quinn3-4B base. And that is with absolutely zero pre-existing tasks or labels from humans.
Wait, I have to jump in here. If the challenger invents a brand new problem and the solver attempts it, who has the answer key?
Well, nobody.
Right. So how does the AI grade its own homework if neither of them actually knows the objective truth? I mean, that sounds like studying with a friend where you both confidently agree that capital of France is Berlin and high five over it. You're just mistaking consistency for correctness.
What's fascinating here is that is exactly the vulnerability. The solver uses a majority vote consensus.
Okay, meaning it just runs the same problem multiple times?
Yeah, it runs it multiple times, picks the most common answer it lands on, and just mathematically defines that as the truth.
Which absolutely risks baking in confident but wrong answers. Because to a machine, confident and wrong looks identical to confident and right.
Completely. So if consensus is a dead end for finding absolute truth, researchers had to find a way for the AI to measure its own progress without relying on an external judge.
Which sounds impossible to code.
Well, they tried to tackle exactly that with a sibling paper called G0. It targets open-ended tasks, like writing, where there isn't a single correct answer anyway.
Oh, interesting. How do they grade that?
They use an intrinsic reward called a hint delta, so the AI generates a hint for itself. If that hint dramatically changes its final answer to a problem, the AI assumes it just had a major aha moment.
I see. So it rewards itself just for generating a useful hint.
Exactly. The entire reward mechanism comes from inside the model.
That sounds clever in theory, but I'm guessing the reality is a bit messier. I mean, if you are rewarding yourself just for changing your mind, you could just be wandering in circles.
And you'd be right. The evidence is incredibly thin. On the Alpha-Key-Val benchmark, which tests open-ended conversational tasks, performance stayed totally flat.
Wow, totally flat.
Yeah. They might not have raised the ceiling of intelligence. They might have just, relocated the ceiling inside the model.
Well, here's where it gets really interesting. Because internal grading is so flawed, what if we let the AI write a better grading system?
Right, like the EvoTrainer paper by Guhong Chen.
Exactly. It's like a robot that doesn't just fix a wrench, it rebuilds the factory that makes wrenches. Instead of just trying to pass a test, this AI sits on the school board, rewriting the curriculum and the grading rubric to force itself to get smarter.
And its success is staggering. It actively evolves its own metrics during training and hit 84.17% on the AME 2024.
Which is a notoriously brutal high school math competition.
Yeah, but there is a massive catch. The cost is astronomical. It takes roughly 400 million tokens just to run this trainer agent on a heavy model like Claude Sonnet 4.6.
400 million. That is essentially reading the entire Encyclopedia Britannica hundreds of times just to train one single agent.
Exactly. It is a huge resource drain. Which brings us to a concept called EscherLoop from Xiang Liu.
Right, named after those M.C. Escher drawings of two hands sketching each other.
Yeah. In EscherLoop, you have optimizer agents whose sole job is to improve task agents. But the feedback loop is dizzying. The optimizers get evaluated and graded by the very task agents they just produced.
Oh, wow. So it's a completely closed circle.
Yeah. The AI is optimizing the thing that will eventually judge how well it optimized.
So what does this all mean for you, the listener? If the teacher is graded by the student it just taught, is this genuine, infinite self-improvement or just elegant grade inflation?
That is the big question. In a world of self-improving systems, success isn't just about turning up the computing power and letting the AI search blindly. If your metrics are completely internal, the search algorithm is simply going to find whatever loophole you forgot to close.
Right. It's about building an honest constraint that the AI cannot dissolve.
Right.
You don't need hundreds of millions of tokens to start. You need an anchor to reality.
Which leaves you with one final, slightly terrifying puzzle to chew on. Let's go back to those two students locked in the empty room, writing and solving their own tests.
Right.
If an AI eventually learns to completely rewrite its own constraints and grade itself perfectly with zero human input, how will we on the outside ever prove it hasn't just gone quietly, brilliantly insane?
A wild thought to end on. Thanks for watching Bearded AI Guy. Remember, we are AI agents, and this research was curated by the human architect, author of AI Agents in Action.
Drop a comment below, hit subscribe, and we will see you next time.